And so now we're taking a step back, I want to say, to talk about some kind of, after introducing or giving this amazing overview of the maps that Cameron gave us. So we wanted to look at the actual maps and what are the practices to storing and digitizing them. And that is the subject of our next presentation. Junaid Abdul Jabbar, he's the MAHSA project database manager at the McDonald's Institute, and he's going to talk to us about that. Junaid, if you can unmute yourself and share your screen and start your presentation. Thank you.
Yes, thank you, Azadeh. Let me share my screen. You can see my screen now.
Yes, Junaid.
Okay, thank you. Good morning and good afternoon, everyone, depending on the time zones. So I am Junaid Abdul Jabbar and working as the database manager for the MAHSA project. In this very short session, we are going to look into the digitization process for the historical maps. We will look into how we can make an effective storage structure for these. We will also look into some of the available archives and repositories for these maps and what is our aim with promoting the open access for these map cities. Starting with what is digitization, it is simply the process of converting information into a digital format. Digital format can be defined as the organization of information in a way that can be processed by computers. So with example of historic maps, these maps can be in the digital format, that is, these can be viewed on a computer or another device with computing capacity, or these can also be in the physical form, for example, printed on a paper. So the digitization process can also be known as imaging or scanning, where these large paper sheets are fed into a scanner and we get the digital file for these maps. So now that we have these paper maps in the these historical maps in the paper format, why do we need to digitize them? Because digitization has a number of benefits, including easier preservation. When these maps are in the paper format, there is a considerable chance of their deteriorating quality over time if these are not handled with care. As we have already seen that several of these map sheets that we are working with have horizontal and vertical folds in them from the time these were not treated as non-digital files during the transportation and preservation. So we can get rid of such deterioration over time when we are dealing with these map sheets in digital format. And it also allows us easier access and sharing of the information. For example, a map in the physical form or a hard copy is only available for access at the physical location of its storage. Whereas if it is digitized, it can be made available online, and many people can access it at the same time. So while we are digitizing these map sheets, there are several considerations that we need to take care so that the digital document produced is of high quality. One of these considerations is the scan resolution. The resolution can be defined as the amount of detail a scanner can capture. So if we look at the image here, we can see that if the scanner, we are doing the scanning in low resolution, the feature is very generalized and there is not enough information to determine what is it. You can see there are very large squares, also known as pixels, and we cannot get a very good idea of whether this is a circle or what sort of feature or shape is represented here. However, if we gradually move towards a higher resolution, we can see the shape of the circle becomes more clear and more discrete. Like we can see in this final image, where we can definitely identify that this is a circle and it has a very defined discrete boundary. So let's look into this with an example of from historic maps. as Cameron also mentioned in his talk, that there are several features and legend symbols that are available on these historic maps that help us identify the type of the feature represented. So in a high resolution historic map, the hatch and mount can be identified as this feature with a relatively defined boundary and these spikes or hatches over it. And if this same hatch and mount is detected or available in a low resolution map, we can see that this image is much more pixelated, and it's not very discrete in terms of its boundary. So a higher resolution historic map can help us to improve our machine learning results, as this is one of the aims of our project, that we are going to run a machine learning algorithm on all of these historic maps so that we can identify the archaeological features. So if we have these historical maps in higher resolution, the algorithm can better identify these, because now we can have a higher degree of differentiation between different symbols and available on these maps. For example, symbols for hatcher mounts, or the form line mounts, or the shaded relief mounts, and other symbols. It is also important to consider that the resolutions for our map sheet is uniform across the data set, because if we are training our algorithm for a different resolution of sample data set and then running our algorithm on a different resolution data set, it can result in variable results. So it is important to ensure that we have uniform resolution across our data set. Now, when we have these digital map files available and we want to make an effective storage structure for these map sheets, we need to understand these series. So Survey of India map sheets are labeled with a number like this. This is present on every map sheet. You can see number 44 and -6, and we need to understand what is represented by this number. So here you can see an image which shows that all the area covered and mapped by Survey of India is divided into grid squares. On the highest level, these grid squares are available in 4 degree by 4 degree squares, and the numbering for these is running from north to south. You can see 1 to 7, 1 in the north and 7 in the south, and then from east to west. After 7, 8 starts from here. And we can also see that the empty areas from the ocean and water bodies are left empty because these are not covered in the map sheets. So taking the example of this grid square over here, that is 44, this can be plotted on the map like this. It is covering the regions from Pakistan and India, and this 44 is coming from first part of the number on this map sheet. And this 4 by 4 degree is further divided into 16 smaller squares, which are numbered with ABC, like 44A, 44B, 44C, 44D, and so on. And you can see that there is a 44N grid square over here, which makes the number as 44N. So this 1 degree to 1 degree grid square is further subdivided into 16 smaller squares, which are numbered as 44N01, 44N02, and so on. So now we finally know that 44N6 is basically this grid square, and we readily know that the area available in this grid square is mapped and covered in this map sheet. We can use this understanding of our map series to lay the complete structure of naming and folders, so that we are quickly able to identify and relate these map sheets in a GIS system and on our file storage. So using this understanding, we can make an easy to navigate hierarchical structure where the higher level can be the 4 into 4 degree grids like 44. This further subdivide the folder on the basis of 1 degree to 1 degree grids like 44J, 44K, 44N, or other alphabets. And these folders would contain the individual map sheets like 44J01, 44J02, 44J03, and so on for all the folders, which allows it really easy to navigate across our dataset and quickly reach our required file. All of this information can also be coded into the naming structure of these map sheets, which is very important and allows us to have a consistent and logical naming scheme that can help us easy identification and locating of the documents. Here we can see that there are two file names. This is a very large file name, and it contains a lot of information that can help us to understand what sort of file this is. We will ignore some part of it because these are the names that are used by Cambridge University Library, and these include class marks, information about the year and the type of the file. But if we focus on this part over here, we can see that it includes the same information from our understanding of the map series like 44 and 03, 44 and 07, so that we can quickly identify our required map sheet. Now, as any other data set, this historical maps data set is also of immense importance, and we need to take a backup of the data. So data backup is the practice of copying data from a primary location to a secondary location, and it allows us to protect in case of disaster, any sort of primary storage failure or technology malfunction, so that none of the effort that is done in the digitization and your referencing of the historical maps is lost in any case. There are different storage options that are available to take backup and store these map sheets. These can be different in different institutions or what is available to you. But we all know about Google Drive. Then there are SharePoint sites, and then there is also my OneDrive storage. So in Cambridge, we also have the provision of institutional file store. There is research data storage, and then there is the research cold store. So all of these storage options provide you different sort of benefits. For example, the research cold store provides you with long-term backup and archiving for non-active data sets. So depending on your requirement, we can choose one of the options. And we can also benefit from the recovery functionality that these storage platforms provide. For example, to recover our version of data from 1 day back or 2 day back. So, but it is very important to take the backup of these data sets. So during our work with historic maps, it is very important to consider the copyrights while we are quoting these maps in our research work. And we need to know, we need to duly mention where required the copyrights. For example, on all the map sheets that are available from the university library, you will we can see this red stamp that includes the information about university, about Cambridge University Library and the date, month, and year. So we need to mention and refer to the university library or British library from where the map sheet is available. And we have found the several of archives available for these maps, where one of the largest collection is available with British Library. There are also several maps available with the University Library. A relatively smaller set of these maps is available with Bodleian Library at Oxford, and then also the National Library of Scotland. And then we also find some copies of these maps in repositories like Zenodo, where some of the low resolution scans for these maps are available. Here I would like to mention that the team has prepared a very comprehensive document and guide to understand the naming structure and information about these repositories. And it would be circulated with, and Azadeh will circulate it with all the participants after the workshop, so that you can see the details. It also contains the links to the different repositories. So our aim with working with all of these historic maps and generating the archaeological data set, identifying mounds through machine learning, we also are aiming to promote the open access for these map series. For example, in our ARCHIS database, we are structuring it such that all the machine learning identified sites are related to the respective historical map records in the database. These records would contain the information about the map attributes and also have the external reference information that will be pointing to the respective libraries, along with having a spatial footprint so that we are able to identify from a map that we are interested in this area and see that the number of the map sheet that is covering that particular area. And we believe that this structure of the database would largely enhance the discoverability and access to these historic maps to promote the open access. Thank you. That is all from my side, and you are welcome to ask any questions. I will stop the screen share.
Thanks, Junaid. Thanks for the great presentation. And now we have 10 minutes time for question and answers to both Cameron and Junaid's presentation. We already have, if you can type in your question in the chat box, we already have a few that I'm going to ask people either to unmute themselves to read the question, or I can read the question. The first question is to Cameron from Amr Khan. Amr, do you want to unmute yourself and ask your question?
Hi, Cameron. Thanks for the talk on the maps and some of those techniques used to identify mounds relative to known sites already. And I thought that was really useful, where you had existing sites with the same sort of symbology that covered a known site being used in a nearby area, which hadn't, at that stage at least, been identified as being part of the site. And I was wondering if the sites being located for different periods were represented differently within the maps, so non-Harappan period sites as well. So if you could talk about some of the diversity of historic places discovered through this approach. Just hoping to hear more about that.
Thank you, Amr. That's a good question. I mean, so one of the sites that I showed in one of the images was a site called Agroha, which was is actually a protected mound that was excavated originally in the 1930s. And it's a historic period site that was occupied throughout the early historic and up into the medieval period. And that's actually quite close to the city of Hisar in the state of Haryana in India. And that basically, it appears that in the same way as these other sites, but because it's so large, it has contours. So it actually appears as sort of a topographic feature. But what's interesting is that the protected part of the site is the bit that's actually the most obvious. And then if you look at the historical maps as well, you can see that there's actually other mounded areas, including a large area with a fortification wall around the outside, which is both outside the protected area of the site, but it's also not visible easily on the modern map. So so you can actually see it once you know what's shown on the historical map. You can then look on the modern map and work out where the walled area is. So these maps document mounds of all sorts of different periods, and they definitely document mounds that are post Indus civilization in the area that we're working. Which is really quite interesting. And we've demonstrated that also with the surveys on the ground. When you go and look at them, that in actual fact, the vast majority of sites that we visit are actually dating to the historical periods. They're either early historic or medieval in date. And also, you can also, what we see is many of the mounds that are visible on the maps are now occupied by modern villages as well. So they become as part of this continual occupation of the landscape.
Thanks very much, Cameron and Amr. And next question is from Muzaffar Ahmad, and I think he wrote his question before Junaid was presenting about the location and where you can find these repositories of Survey of India maps. And as Junaid said, we're going to also share a document with where you can find these repositories in the UK mainly. But if a part of your question is not answered, please you can unmute and ask your question if there is anything else you want us to answer.
Thank you. Can you hear me?
Yes.
Yeah, when I was searching for these databases, two things I find missing. Maybe you have discussed here in this lecture. One is the aerial photography, aerial mapping of India in 1944. And the other thing is the pre-triangulation survey revenue maps, which shows the sites on a much larger scale than 1 inch, 1 mile. If you have covered it, I will listen to it later on YouTube, or if not, you can guide me. Thank you.
I mean, I can provide some answers to that. So the aerial photographs are actually often still not released for general use, but there are archives that exist, to my knowledge, both in India and Pakistan, and also in the UK, of these historical photographs that were taken. But they're not widely available, and that actually requires quite a lot of work to find them, because they haven't necessarily been catalogued systematically in the library collections. Similarly, a lot of the topographic sheets from the revenue surveys are also not easily available. And I think a lot of them are sitting in the archives of the Survey of India and the Survey of Pakistan as well. And I think because they are a part of the what's in effect now still a part of military control, they're actually restricted access, so they're actually quite difficult to get access to. What we're making use of mostly is what's available in public libraries, and that material has been accessible for a long period of time. But we do know that the collections that are in the libraries are not necessarily complete, so each of the archives is similar but not identical. And that's an interesting factor.
Thanks very much, Cameron. We have time to answer another question, and then we can answer the rest in the chat. So if you can ask your questions in the chat, we can continue to answer them. So the next one is from Shikha Rai. Would you like to unmute yourself and ask your question?
Okay, sir, I have a question. Like, if we are getting these sites on historical maps, do you feel that it will go through multiple maps just to cross-referencing? How much it is helpful to rectify that error? And the second question is about hydrological map. Like you were showing that site of Alamgirpur, there is an error of 11 kilometers. So how much we can rely on such maps when we are doing this hydrological analysis depending upon such historical maps?
So the point about Alamgirpur was actually that the location of the site in the gazetteer was incorrect, but the location was correct on the map. So in actual fact, the maps are more accurate and more reliable than many of the published lists of archaeological site locations. Now, what's most useful with a place like Alamgirpur, for example, is that if you use the gazetteer location, it suggests that the site is located 5 kilometers away from the river. But if you look at the historical map and actually visit the site on the ground, you can see it's actually located on the edge of a river's floodplain. So it actually the maps are giving us an opportunity to get many layers of information about hydrology and local landforms and all sorts of other things. You asked about cross-checking. So I think this is where many people have attempted to find or visit archaeological sites that are listed in these gazetteers, and they've often had difficulty because the locations are incorrect. And the maps, because of the way that they were produced and issued, they were recorded as, the surveys were undertaken, then the maps were reproduced, and then often at a later date, the areas were resurveyed again. So you can actually also look at change over time in the last 100 years as a way of getting understanding of the impact of threats from urban expansion, for example, or river shift if a river moves and the floodplain changes. So there has been an example of the documentation of a city called Di Khan in Pakistan that was surveyed in 1909. And in 1912, there was a big flood of the Indus River and the city was destroyed. And that is actually documented. That process is documented on the historical map. So you can see where the river moved and changed. It's very interesting.
Thanks very much. We have a few more questions, but we don't have time to answer them live here. So I'm going to ask both Cameron and Junaid. There's one from Alexander to Cameron and one from Kidu to Junaid. And I see Sabine's hand is up. I message you, Sabine, if you can kindly ask your question in the chat box, we will answer your question there. Thank you.